right, here is question 13, method 2. I didn't really like the other method I used there. I think we can do it a lot better, actually. So how I would do that, I think if I was not exploring ways, I think I would differentiate first. So we want to find, these are the distance equations, we want to find the velocity equations. So rather than making these two equal to each other like we just did, and then differentiating, and then solving for t, why don't we do it the other way around? Why don't we differentiate first, make them equal to each other, and then solve for t after? So I think there's going to be less messing around. Let's have a play with it and find out. I've got the two equations. I'm going to say s is equal to t squared plus 13. In fact, I'll write the equation out. It's going to be x 13.02 question 13. Okay, here we go. So this is 13t plus 19. And we've got s is equal to 7 plus 5t plus 3t squared. So let's differentiate those. So the first one, that's 1 and 2. So velocity 1, I'm going to call it. This one here. It's going to be 2t plus 13. And velocity 2 is going to be 5 plus 6t. 6. What am I writing? T what? 6t I'm writing. I've just been doing this all day. That's no good. 3 times 2 is 6t. There we are. Sorry, I'm making mistakes. I don't mean to. All right, so now we can make these two equally to each other. And let's see how this plays out. So I've got 2t plus 13 is equal to 5 plus 6t. So I'm going to subtract 2t from both sides. So I've got 13 is equal to 5 plus 4t. Let's actually subtract the 5 from this side. Minus 5 minus 5. So 13 minus 5 is 8. So 8 is equal to 4t. Divide both sides by 4. Here it goes. So now t is equal to 2 seconds. Now again, you want that clarifying statement, and you want to be able to say that the two objects will be moving at the same speed when t equals 2 seconds. So you want to be able to state that. Anyway, that's the way, my preferable way of doing it. I think there's less messing around and less things in order to manipulate to get finding the answer.